Hi, this is Brian Kim. I want to share with you this case of a patient who had cataract surgery with me almost about a year ago. He had cataract surgery in the left eye with a single piece acrylic lens. Everything went well. He was 20/20 vision uncorrected, and I was expecting him to be happy, but he was absolutely miserable. Why? Because he could see that there was a blind spot in his temporal vision in this left eye. We did a visual field formal test, and it showed a defect, and I was really surprised by that. But then we repeated the test and it turned out to normalize. We also got an MRI just to be on the safe side of his brain, and that was negative as well. And so we are left with a negative dysphotopsia. He was very patient. He tried to adapt to this situation, but I explained to him how some people notice the edge of the lens implant because the implant lens is flat like a coin, whereas the natural lens is big and round like an M&M candy. And so this is going to be the removal and exchange of this lens for an LI61AO lens in reverse optic capture configuration. So you can see the lens, it's perfectly centered within the capsular bag. I have a perfectly round rhexis with equal overlap over the IOL optic edge. I make my incisions first on the right side and then the left side. This is intracameral epinephrine, and this is the IOL capsule dissector that I've developed with Epsilon. Again, this is a prototype. You see it's flat, so it can get underneath the rhexis edge. But I'm using this, again, dispersive is also mounted on here. So I'm just fill the chamber with dispersive viscoelastic using this cannula, and then I make my incision. I make a vertical groove, place the blade into the deep part of the groove tunnel, and then I enter. So rather than switching the viscoelastic cannula to this one, I went ahead and did it early on. Well, my technician did it early on. And then I'm going to slide this capsule dissector under the rhexis edge, which goes under very easily. Again, this surgery is probably about 9 months ago. I'm sweeping and pushing dispersive viscoelastic to separate the anterior capsule from the posterior capsule. And I'm going around 360 degrees if possible here. Sweeping and pushing dispersive viscoelastic as I go. And so freeing up the anterior capsule was pretty easy in this situation. And here I'm trying to free up the peripheral capsule. Again, the anterior and posterior capsules are adhesed in the capsular fornix. So I'm trying to sweep and tease around the leading haptic. It looks like it's a little bit stuck there. Try to sweep some more, but I'm not going to really perseverate. I don't want to cause any damage and stress to the zonules. And then I'm sweeping underneath the area of the other haptic as well. This is a Lester. I'm trying to disengage the peripheral haptic from the capsular bag, and you can see it's really stuck. And so really shouldn't perseverate in this situation. You can see there's quite a bit of incarceration of the haptic. You can see the peripheral bulb of the haptic is incarcerated with the capsular bag material. Using some cohesive viscoelastic to try to separate the haptic more from the bag, but as you can see here, it didn't really quite work. And so rather than perseverating, I'm just going to switch to the other side and see what happens. And it's a little bit of the same. You can see there's quite a bit of fibrosis around the tip of the haptic, around the bulb of that haptic. And so here I'm going to use microforceps as well as this capsule sweeper, this capsule dissector. I'm trying to tease the haptic from the capsular bag. Again, this is a fairly delicate maneuver. And of course, if you're not careful, you can puncture the capsular bag. So I'm just trying to be very careful as I try to do this maneuver here. And it's helpful to have counter traction with that microforceps to just immobilize the optic as I try to sweep the haptic. So at this point, I decide I'm going to just go ahead and amputate the haptics, push some cohesive viscoelastic underneath the optic to push the posterior capsule back. And then we're going to go ahead and just amputate the haptic. So here you go. Go ahead and amputate that haptic. And then I'm going to go ahead and cut the optic. Being careful not to puncture the anterior capsule rim or the posterior capsule. Switch the instruments to 2 forceps. And then carefully pull that first half out of the eye, grabbing the cut edge of the optic. And it comes right out. And then using a forceps and scissor here, I'm going to pull on the lens, and then we'll cut the other haptic as well. Again, taking care not to stress out the capsular bag or the zonules too much here. And then switching to another forceps, we'll go ahead and pull the lens piece out. I'm going to turn that lens. You can see the haptic is going to act like a hook, and so I don't want to pull it out that way. So I turn it 180 degrees, shielding the cornea with the other forceps, and then pulling that lens piece out. Filling the bag with cohesive viscoelastic, and this is the injector for the LI61AO lens. This is a 2.4 size. Pushing the plunger down, making sure the leading haptic goes into the bag. The optic is delivered. Withdraw the plunger and deliver the trailing haptic, pushing down on the optic with the other forceps. Using the Lester to dial the trailing haptic into the bag. Repositioning the lens, making sure that both haptics are in the bag. So I decide to go after that trailing haptic, and I grab the edge of it, the cut edge, and as I pulled it with microforceps contra-incisionally, fortunately I was able to pull that haptic out. I looked for this other haptic as well, but it really retracted far into the fornices, so I didn't feel like it was worth going after that piece, so I left that haptic in. I go in with irrigation off, activate irrigation, go underneath the lens, removing all the viscoelastic from within the bag. And listen, I've done this technique using reverse optic capture for the LI61AO lens, and I've tried to use 2 instruments and this and that and so forth. And I think what I've learned is the best technique is just using the IA and basically lifting the lens up, tugging it towards me, and buttonholing the lens with just one-handed maneuver. Just a one-handed maneuver, lifting the lens with the INA handpiece. As I lift it, I pull the lens towards me, which then initiates the buttonhole configuration of the LI61AO lens. I'm removing all the viscoelastic from the anterior chamber, and then I'll hydrate my incision. So again, this patient had significant negative dysphotopsia. We did a visual field testing, which showed that he had a visual field defect. I was really surprised by that. We repeated that field test, and it normalized. It was my understanding that negative dysphotopsia did not actually manifest in formal visual field abnormalities. I was a little surprised that it showed an abnormality, but we went ahead and repeated. It was negative. He had an MRI of his brain as well, again, just to be on the safe side, and it was negative as well. This patient then ended up having the lens removed, but you can see the haptic tips were really incarcerated within the peripheral capsular bag. So I amputated each haptic, took the optic out, placed the lens into the bag, and then was able to carefully tease out and pull out the trailing haptic by pulling the cut edge, and popped out. But again, the leading haptic was so far in the recesses of the capsular fornix and not really visible, I just decided to leave it alone. And now this patient has an LI61AO lens within the bag with the reverse optic capture. Again, I've done it in many ways. It's my personal belief and experience that the best way to buttonhole this lens that's in the bag is to use the INA handpiece to get underneath the lens and then lift it up. And why is that? Because these haptics are more bendy than the other PMMA haptics that are out there. The haptics are more bendy, therefore when you lift the optic, it pops up and the haptics just collapse a little bit. And so now you can see a perfect almond-shaped cat eye configuration of the reversed optic capture. You can see right here very clearly and very nicely. This patient's negative dysphotopsia was dramatically improved after surgery. He was very happy. He was smiling. And you know, he went from 20/20 uncorrected vision to about 20/25. I shot for first plus, which was around a +0.5 by using the reverse optic capture configuration, but he ended up like a -1 +0.25, but he's still very happy with his vision. What's interesting is even though he had better uncorrected visual acuity with the in the bag single piece acrylic lens, he prefers his vision now with this reverse optic capture of the LI61AO. And that is primarily because he just couldn't stand that shadow that he was seeing. And this patient was very happy. Again, utilizing the LI61AO lens with reverse optic capture, using the INA handpiece to create that buttonhole configuration. So I hope this was helpful to you, and I thank you for your attention.